announcements. You can still sign up for eCTF, and I think this deadline's extended till the 5th, might even be extended more than that. So if you want to join this team to hack embedded systems, you might want to do it. It's from MITRE, very good company. I'm sure it's a very educational event. They do need people with some skill in programming. And there's a hacking workshop this Saturday. Feel free to come here or connect by Zoom remotely and attend this. It's worth extra credit and should be very good. And you can't beat the price. So this is 125, and we're up to the last chapter. This is the last lecture in this class. We're pretty much at the end of everything here. We'll do the last section on software development security. There's one more class after this, but I'll just answer questions. I won't add any new material then. I'll just help people that want help. All right, so let's take a look at these slides. So, programming. When you write a program, you typically write it in a high-level language like C or C++ or Python or Java, and then it has to be converted into machine code in order to run. Machine code is the binary language that the processor can handle. It's just a bunch of ones and zeros. It's very difficult for humans to understand. So humans have something called assembly language, which is just a way to write down machine code that makes it a little bit more readable, but not all that readable. They have commands like add, subtract, and push, and each command just moves a few bytes of information around. So the compilers translate source code into machine code for compiled languages like C and C++. Other languages like Python use interpreters where they translate the lines of code one by one when you run it instead of making a separate machine code file. And there's another type of language that is platform independent like Java, where you compile the code partially into an intermediate form, which is not assembly code or machine code. It is something they call bytecode, and that is something which runs in a virtual machine, a Java virtual machine. When does Cyber Skyline extra credit due? Well, if you want to turn in anything extra credit, turn it in by the last day of the class. So that would be December 9 for this class. Any kind of extra credit should be in by the last class. All right, good. A good question. All right, so anyway, procedural languages, you have subroutines, procedures, and functions. Object-oriented languages define abstract objects, which can inherit properties from parent objects like C++ and Ruby and Python have these fancy features. And you can see it in Metasploit. Metasploit is now written in Ruby, so you see it creates a class called Metasploit, and it has things in here, and so you create a class, you have these double colon things that indicate a part of an object. Objects have attributes and methods and so on. So you create objects. Your code lives inside these containers called objects, and you can duplicate objects. And then there's fourth generation languages that supposedly automate creation of code. I've never used any of these. Cold Fusion, Progress, Oracle reports. I don't really know how they work. Nowadays, I use large language models to write code. Everybody does. There are several of those, like Copilot, that will do some automatic generation of code, but there was some earlier automated generation back here in these things called fourth generation languages, which I never used. Anyway, so computer-aided software engineering is when programs help you create and maintain other programs. There's tools, workbenches, and environments. And so you have these GUIs and such. The main thing I know is an environment, Visual Studio. That's where most Microsoft coders write their stuff, a Visual Studio suite. So there's top-down programming where you start with the high-level requirements like a block diagram of what you want to accomplish, and then you write the code. That's what you do in procedural languages I'm used to. Supposedly object-oriented code starts with low-level technical details. I haven't done that, but that's what they say. Closed source code is commercial code like Microsoft Word. You cannot get the source code. It's a proprietary secret, so you can't modify it and compile it and make your own version easily. Open source is where the source code is publicly available, like Linux and other products, so you can modify it if you want to. It may be free, or it may be in the sense that it costs nothing, or it may be free in the sense that it's available to modify. And so there's freeware that doesn't cost anything, shareware with a trial period, and crippleware that gives you a limited version of it for free, and then you don't get the full product unless you pay. So public domain is where it's just free to do anything you want with it. Proprietary software is copyrighted and may be patented. You can't do anything with it except what you're allowed to in the user license, which typically means you can run it on one machine. You can't give a free copy to somebody else or sell it or anything. You have a license agreement determining it. there's quite a few different open source licenses, and your open source people make a big deal about moving from the GPL to the BSD and such. They get very mad about it. I've never been too interested in it, but anyway, there's several different versions. Yeah?
I have a question. The quiz had a question on software licensing.
Yeah.
And I thought that GPL was the correct one because it's an actual license. Let me read you that.
Oh, yeah. Well, I don't know.
Because I know the question was, what license makes software free for all uses?
Okay.
Of course,
That would be public domain, I think.
Public domain.
Right. These other have restrictions. You can't just do anything. For example, they say if you do modify it, you must distribute the source code with anything you put out. Some of them say you can't make something and sell it. So all these do place restrictions on it.
Okay.
This is what you mean if you have no restrictions. Totally free. You can do anything you want with it.
Okay.
Yeah, good. Okay. Very good. Thank you. All right. So anyway, free as in free pizza. Yeah, Richard Stallman. Yeah. All right. So then there's methods of how you develop. The original one from the 60s was the waterfall model, where you just have stages. You make your requirements, system requirements, software requirements, analysis, program design, coding, testing, and then operations. So you just imagine that everything passes like an assembly line. This team does something, that team does something, like building a car. You stick on the doors, you stick on the tires, you stick in the engine, and then you have a car. This is a very simplistic assembly line way of doing things, and it turns out this doesn't work very well for software at all. The problem is, you might do one stage, and then a couple stages later you discover it's not working, and you have to redo that earlier stage. So they made another one where you can go back and have rework, which is the modified waterfall model that came in later, and then there are many other models to try to deal with the actual complexity of software. And software really, really leads to a self-defeating thing where one team can make their job easier by making trouble for another team. And so the sashimi model has overlapping layers of code here with people and teams overlap. Then there's agile development, where you just try to operate really fast and give people a lot of freedom. With the Agile Manifesto, better ways to make software by helping others do it. Scrum is where you have one team that does everything, and they move on to the next and next, and that's the idea where hopefully they can't just dump all their problems onto some other team. It's going to be you again doing that next stage, so you really have to solve all the problems. Extreme programming is where pairs of programmers work, so you look at each other's code and therefore hopefully catch more mistakes and such. All right. Spiral is where you go through many rounds, like you see here, where you have the requirements, then you do a risk analysis, a prototype, then you get some version of it working, then you decide so you start here, then you go out here, another risk analysis, another prototype, change it again. This is kind of more realistic, like, if you have something like Windows, you keep having to have patches and updates, and then the patches cause trouble. Anyway, it's just another way to do it. People have tried all these different things. The one I don't see here is the one I read most about, DevOps, where you organize your business to prevent things going back for rework as much as possible, focusing carefully on that to make everything much more efficient. But that's a modern technique and not listed in your book. Anyway, rapid application development is where you have quickly do simple versions to get something that looks pretty good to meet business needs. This is something I'm often telling my programming students at the other college. They want to say, this programmer template is right or that one's right. And I say, no, they each have a time and a place. It depends on what you're doing. Sometimes you have to have a demo working by next week, so efficiency doesn't matter. All that matters is getting it done fast. Sometimes you have to have a beautiful, perfect one that runs as fast as possible. There's not one answer. You have to meet the business needs. All right, so prototyping is where you make a version of it that has only some of the features working. Maybe part of it only looks good but doesn't work, things like that. So you can demonstrate to somebody, here's what I'm trying to do, so you can ask them for funding or ask them to approve further development, saying it's going to be like this. So you see realistic looking results. System development lifecycle or software development lifecycle is something where security is included in every phase. Microsoft has been a champion of this, and it's in a NIST. It's in a National Institute of Standard now. So initiate the project, then you develop and acquire the components, then you implement it, then you operate it, and then you dispose of it. And you should have a security plan right from the start. So you prepare a security plan, define your needs and purpose, consider the sensitivity, what risks are there. Then you develop it, determine security requirements. You implement it, installing controls, testing, and accreditation. So you implement controls to limit harm. Then you test it to see if your controls are working, and you have accreditation, which is meeting some kind of standard. Then you operate and maintain it, and you're going to have to keep testing it during the period of operation with updates, backup training, and so on, audits and monitoring, and then you dispose it. You have to archive what parts of it will be kept and used for later, and you have to sanitize all the old media of the hardware you're throwing away so you're not leaking out confidential information, like source code, which is generally considered confidential for closed source projects. So you have an integrated product team is a team that focuses on the whole life cycle of a project and tries to make sure it's pleasing the customer. And there's software escrow, where you put the source code at a trusted third party so that if the product is abandoned, the customer can get the source code in order to maintain it themselves. If their business relies on this product and there isn't another product for them to buy, or they don't want to buy it, they get the ability to understand the source code and maintain it themselves. That's a big technical debt. Most people are not willing to do that, but it is an option sometimes. You put that in the contract. So you can have a code repository. This is a huge problem. A lot of shops had their own internal code repositories, and then they decided to put it on GitHub, and the person who put it there did not realize that there were secrets in the source code. This is a huge problem. It keeps happening over and over. The source code has passwords, API keys, and other things hard-coded in it, which it should not, but in earlier days, people didn't know not to do that, and they wrote that code. You probably have some old code dating from those days, and when somebody just slams it all on GitHub, they often don't realize that. GitHub does have the option to scan your code for passwords and keys and warn you, but people don't always turn it on. So there's an enormous number of secrets published on GitHub. Then you have APIs. APIs are listening services that take requests from other apps like computers or cell phone apps to ask you for something. Like you log in, send an OAuth request, then it sends a request to get like your picture to put on your page and so on. So API exploits abuse the API to compromise security, and APIs are extremely vulnerable in most cases. People often neglect to put security on them. So there's OWASP has a toolkit, the Open Web Application Security product, to help you do all these important things at your API, have authentication and output encoding and cryptography and so on. All these things are what you must do correctly if you want your API to be secure, and a lot of them are just hastily deployed, and they're lacking these things. Someone said, I just want to have this conversation. I want to use GitHub Enterprise. Yes, it's a real important conversation. A lot of people want to move to the cloud, and yet when they move to the cloud carelessly, they expose confidential information. So if you do move to the cloud, you have to do a review, make sure you do it correctly, and then do an audit later to make sure you didn't accidentally publish the stuff you shouldn't have published. Of course, you can make a private GitHub repository, and that's pretty good. That's a step forward, but you know, it is a real important issue of any kind of moving to the cloud, putting your stuff on Azure or anywhere, or in Amazon buckets. You have to make sure you understand what you're putting there and that you put appropriate controls on it. Many, many people fail to, and they end up publishing stuff they shouldn't have published. All right, so then you have change and configuration management. When you make changes in the software, you may harm security. So there's a configuration management plan with a control board. You identify the items, you have change control, and then monitoring, just like other changes. Rather than, you don't just arbitrarily make a change like Cowboy. You propose the change, people review it, they decide whether it's worth doing or not, and if they do it, they do it carefully with, say, a rollback plan so they can undo the change, and some kind of test and auditing to see if the change actually created more problems. All right, and then I mentioned DevOps is the new system you find in the book called The Phoenix Project, which is a wonderful book. I highly recommend reading it, that explains a new way to do this where you don't have a separation between developers, quality assurance, and production. Everybody works together, and everybody has to have coding skills so they can automate their job, and each team, the team before you that hands you stuff, you are their customer. So if they hand you stuff and it's not well done and it makes trouble for you, you complain to them and they have to fix it. So you're not allowed to have things going backwards for rework. If that ever happens, you have to focus on that and fix it so that won't happen again. And that makes it That's what Amazon invented this, and Amazon now has 144,000 rollouts of new code per day. The Amazon website is not a fixed thing that has like a version 1.1 and a month later a version 1.2. It's like a living organism, constantly changing. Tons of developers are constantly changing it because they have this very efficient process where you develop something and it efficiently goes through all the stages of testing and compliance, and within like half an hour it hits the website and is there. So that's DevOps. All right, let's try a Kahoot. 8A is here, all right. Oh, I should make this a little skinnier so people can see the number. There we go. DevOps, yeah. There's even DevSecOps, which I really don't know what that is. But DevOps I understand because I read the book. It's a very fun book. There hasn't been a similar fun book about DevSecOps, so I don't have much of a clue exactly what the heck it is. All right, so what code contains commands like add and push? That's assembly language. All right. Each command does just a little bit of work. It takes a lot of commands to get anything done. All right. Which method has no process for redoing a previous step? That's the waterfall method. As you imagine, if water falls down, it never goes back up. Turns out to be very unrealistic for software products. All right, which one of these is agile? XP, it's XP. Boy, let me go back. I don't remember that one very well myself. Let's get back to this Agile stuff. Okay, there's Agile. Yep, Scrum and XP. Okay, fair enough. That's what they call them. All right. By the way, notice I still don't know what XP is. Remember, the CISSP is a mile wide and an inch deep. You know these terms and you only have a vague idea what they are. That's what you're going to get in the CISSP, which is the level of many managers. Anyway, all right. All right, so which technology allows apps to use a service like Facebook? So you could like log in with Facebook. That's APIs. We offer some kind of programming service to requests that come in from apps. All right, I think two of those I know who they are, but hard stuck will have to tell me who they are if they want their points. All right, anyway. All right, so, we're on track here. So, databases, my favorite topic. I used to be a DBA, so, all right, so it's a structured collection of data. And so you can do queries where you search through the database to find things, you can insert and delete data, and you have a database management system of some kind to do all that. So database administrator is like the network administrator, or the domain controller administrator is the person with enough power to create and delete and modify databases, and they do it with a query language. Typically, most often SQL is the most common one. And so there are various kinds of attacks. If you have a database that has high security data that is not available to everyone, sometimes a low privileged user can deduce it. They can do an inference attack by enumerating the low privileged data and seeing what's missing, and deducing that if there's some kind of sequential index, like an ID number, they can find out what ID numbers are missing, and then they can say those must be the high security things I'm not allowed to see. And then there's aggregation attacks, where you combine many low privilege records to deduce high privileged data. These are very similar, but they're security failures, where high security information leaks out into a low security channel in an indirect way. So relational databases are the most common, but there are others: hierarchical, object-oriented, and of course flat files. It's a simple text file. So a database structure, you have tables, and each table has fields, which are the columns, and then you have records, which are the data. So you have name and SSN, and here you have a series of names of people and SSNs. Then you have another table over here, and so on. That's the kind of structure. All right, so tables have rows and columns. There's a primary key, guaranteed to be unique, to connect the tables together. This is why everybody has to give you an ID number. A couple decades ago, everybody used social security numbers. Then they decided that was not legal for anybody except the government to use. So now everybody has to assign you an ID. You got a Safeway ID and a City College ID, and every company assigns you an ID number, because of course they can't use your name, because people have different versions of their name, and they have nicknames, and then women get married and change their names and all that jazz. So the name might not be unique. There are other customers with the same name, so they have to give you a unique identifier. That's the primary key. Now, a foreign key is a field that matches in another table. The most common situation is customers and orders. You have a list of customers, and then each customer has many orders. And later on, they might have more orders, and so on. And so you connect them by their customer number. And that's called a join, connecting two tables by defining a matching field. So referential integrity makes sure that the keys match, that there are no duplications of the primary key, there's no record that lacks a primary key, and they match. Semantic integrity makes sure that the right kind of data is stored everywhere. If you have a numerical field, like a dollar field, you can't put letters in there like names, just money. And entity integrity makes sure, like I say, that there's nobody lacking a primary key. This is all called integrity. So here's a database table lacking integrity. We've got a duplicate social security number, which is the primary key, so that's bad. And we've got vacation time and sick time, but sick time has nexus 6 in where it should have just days. This should just be a number, and it's got a non-numerical data, so those are both failures of integrity. All right, so you can normalize your data to remove redundant data. If you don't normalize it, and you have like multiple places where an address is stored, then when you update the address, you might not get them all updated, and then you'll be sending out 2 and 3 documents to people, and they might each have only part of their information. That's why it's better to reach these normal forms where you make sure that there's only one place to store every piece of data, and therefore you have one copy which you keep up to date. All right, there's database views. This is essentially what you have at like a cash register. If you go to like McDonald's and you buy a hamburger, the clerk at the counter brings up a page that just has a place to mark, you got a burger, you got fries, you got a shake, then they press enter. They're seeing information about one transaction. Now, there are millions of transactions in a database, but they see just one in a friendly interface, and the same thing's true if you log into Gmail and you go to your profile. You see your picture, you see your place to change your password, and so on. You're seeing your information. There's millions of other people's information, but that's a view that shows you only a friendly view of just one record of information. All right, data dictionary describes the table, data about data. It's also called the data schema, a very similar thing. I don't know the difference. They both seem the same to me. It describes the attributes and values of the table. This will be a list of all the tables and the fields and the types of data stored in the fields. So here's a schema. I have an employee table, and it's got SSN, name, and title. And here it defines how these are defined. Name and title have 30 characters. SSN has this particular series of numbers with dashes in it. Then I have HR is another table that has SSN, sick time, and vacation time. So here we are, by the way, doing this illegal thing, which I mentioned. We're using SSN as the primary key, which would be nice, but it's not legal for anybody to do that except the government. That's why everybody has to give you a different number. Anyway, that's how it works. So you got data definition languages and data manipulation languages. The most common language is structured query language that has both of these. There are many versions of SQL. MySQL is the open source one. Microsoft has ANSI SQL. Oracle's got PL SQL, and so on. They're all very similar, a few minor differences between them. So commands will be like create to make a table, insert to insert a record, delete to delete a record or a table, select a record, update a record, and so on. So you have things like this: select star from employees where title equals detective. This will give me all the information in the table about these employees who have this field at that value. All right. So you got a hierarchical database. DNS is an example of a distributed hierarchical database where no one machine has all of it. You have the root, which has only information about the top-level domains, and then each top-level domain has information about the primary domains under it, like google.com, and then the Google's domain server will have information about the specific machines at Google, and so on. So it's a hierarchical database where there's a series of servers that each have a little different amount of it. All right, and so object-oriented databases use object-oriented programming to store objects in your database instead of just numbers and text. Do PTO limits exist because the DB can't handle more than 3-digit numbers? Well, yeah, that could happen. By the way, I just hear I listened to the Security Now podcast, which I recommend, and they just passed episode 1000. And of course, Steve Gibson wrote all the software, and he had to change all the software to handle a 4-digit episode number. So he talked about that. This is a big deal when companies move from IP version 4 to IP version 6 too. A lot of people have hard-coded fields for IP version 4, and IP version 6, the addresses are 4 times longer. So moving often requires a lot of work, updating all your databases and all your software that assumed that IP addresses would only be a certain number of characters long. All right, so database integrity will help prevent mistakes being made in the database. If 2 users try to change the same record simultaneously, which could happen. I used to run the databases for a call center where we had about 100 people answering the phones, and 2 people could call and try to change the same address at the same time. That's a problem. So if you do that, your database management system will attempt to commit an update, but it might decide it cannot make the update because somebody else has locked the record because they're editing it. So then the commit will be unsuccessful and it will roll back and restore from a save point. And there's a database journal which logs all transactions. So you can resolve problems like this. Anyway, so you have highly available databases with multiple servers and multiple copies of tables. You have replicated databases, a copy to live database, and you have shadow databases that are just there as a backup. These are all ways to deal with the fact that you might have your servers go down. All right, and databases usually contain really important information that you really need, like the orders your customers have made today, which you haven't fulfilled yet, but you've already collected their money, so it's really important not to lose that data. So there's data warehousing with huge amounts of data. They also call these things data lakes these days. And once you have a ton of data, then you can do data mining, hunting through here, trying to find information in there. This is what the NSA does. They've got an incredible amount of data archived at a huge installation in Utah, and somewhere in all that, they've got all the emails and everything they got off the internet, and somewhere in there is all the information you want. Every kidnapper, every fraud, every terrorist, there's information in there if you could only find it, if you were smart enough to write the right query to track it down. So object-oriented design, a program is a series of connected objects, languages like Java. Each object has data and methods. Data is information stored in there, like names and social security number. Methods are code that are part of the object. And so this provides data hiding. It's also called encapsulation. I've heard it called abstraction, where now you define something called an employee, and you can then manipulate the employee without worrying about exactly all the things that are inside there. So you got objects, you got methods, which are the active code attached to an object. You got messages that go from one object to another, and some more things here we'll talk about up ahead. So here's an example. Addy is an object that adds things. So it has a method of addition. If you feed in an input of 1 plus 2, it gives you an output of 3. That's Addy. Now, if you want to do subby, you can send it to Addy, and Addy will notice that you have a negative sign here instead of a plus sign, so it will delegate that to a separate function called subby, which knows how to subtract. That's delegation. An alternative is polymorphism, where the same Addy could do two kinds of inputs. You could send it numbers and it would add them, but you could send it text and it would concatenate them. So this is called overloading or polymorphism. Polyinstantiation is where you have multiple records for the same primary key. So if I have top secret input and I ask, tell me about this record, it will give me the whole record, including the top secret information. But if I have secret clearance, I'll only see the secret information, not all of it. Is Oracle dominating the market? Well, I don't think Oracle ever really dominated the market. I mean, Microsoft databases are big. They just hit a different market. Oracle fits the biggest, most expensive companies that will pay a lot. Oracle is super expensive and hard to use. So it's used by big insurance companies and banks and other institutions like this college for some ungodly reason we're using Oracle. I can't imagine why. But anyway, Oracle is for the big enterprise market. That's what it is. And they seem to have a lock there. All right, so object request brokers are middleware that will connect programs to other programs. Corba is the one I hear about the most, but there's also COM and DCOM Microsoft products. Middleware that connects programs to other programs. And so a component object model and distributed component object models are ways for code to be reused. Microsoft is intended to make it easy for developers to sell code. So they make it possible for an object written in a different language to communicate with another. Sort of like an API, a limited kind of API before people started talking about APIs. So you can connect these components together, and the idea is you could purchase code from other developers and just plug it into your network like a component, like a puzzle piece, like Lego. So they did this with ActiveX and object linking and embedding, and now it's all being captured into Microsoft's .NET framework. Corba is the common open source request broker architecture for middleware. Competing with Microsoft's proprietary DCOM, you define an object, and then you define interface definition language to say what kind of inputs will you take and what output will you take, and now anybody can purchase or use this thing by just feeding it the appropriate input and getting the appropriate output. So you can do object-oriented analysis that tries to identify all the objects and interactions, and you can do object-oriented design where you develop a solution. So you got an example of this. You got network traffic sending up packets. You have a sniffer, which gathers the packets into PCAP data. Then you feed that into an analysis object that tries to decide if this is web traffic, client or server traffic, if it's a denial of service attack, and then you go to an alerting object that will take the appropriate action depending on how this is detected. So you define an intrusion detection system this way, by defining these objects, and then you write the objects in object-oriented code and connect them together. All right, let's try a Kahoot. 8B is here. All right. Use it or lose it policies are not legal. Companies can limit PTO. That's right, yeah. Oh yeah, issues about PTO. Oh, I see, I didn't understand the question. I think that happened to me. You build up so much time off. That keeps happening to me at college too. They keep having to pay me more because I keep teaching more classes than you're supposed to. Yeah. If you do more work than you're expected to, then you earn time off, and they either have to give it to you or pay you off with money. Yeah. Well, I really irritated my boss when I was a database analyst because I worked so much overtime that I was being paid more than him. He was not happy when he learned that, but I was working like 100-hour weeks. Kind of insane. You can't do that for too long before you go nuts. I learned a lot though. But mostly I was offended. This is just stupid. You should just hire more staff so they only have to work 40 hours. That's a lot better way to run a company than making people work 100 hours. Anyway. All right, looks like we got everybody. All right, so which attack combines many low privilege records to deduce high privilege data? Aggregation. Now inference is similar, but if you think about it, inference would be you have a series of like phone numbers in order, and all you really need is to have like 2142 and 2144 to deduce that 2143 must be a hidden one. You don't really need to combine a lot of records to do an inference, but aggregation is where you do aggregate many records to deduce something about the high privilege data. All right, so what process removes redundant data? Making sure there's ever just one place for everything, and everything can be found in its place. All right, so which concept allows a component to recognize input it cannot handle and pass it on to another component? That's delegation. Your program notices that it can't do the job, but it knows that it can pass it on to some other component that can do that job. All right, which one is open source and vendor neutral? Vendor neutral. Yep, that's Corba. All the rest are Microsoft products. Corba is the open source middleware product. All right. Mention, of course, admin will have to tell me who they are if they want their points, but they may not care, which is fine. All right, so then you got to determine how your security program, how well it's working. This is important for everything. So there's tons of software vulnerabilities, lots of errors. Something like 1% errors is common. So there's hard-coded credentials. I mentioned before, you might have passwords in the source code. You might have buffer overflows where you define a C string and it's possible to put in more data than expected, which will overflow and cause memory corruption. SQL injection is where you can put characters, unexpected characters like apostrophes in data, which cause data to be misunderstood as code. So you can execute commands on the server. You can do path traversal, where you refer to the location of an object, and it's possible to use .. or other techniques to move to a different directory and refer to a different object than the developer expected. All right, good, I see. Thank you, Jimmy. You're not registered for class, that's fine, and you don't care about points. And then remote file inclusion is similar to path traversal, where you have a PHP script that refers to a file, and you're able to change that file name and refer to a different file. So you might be able to include a different file on the same server or a file even from a different server in the page. These are very common vulnerabilities. There are many others, but these are kind of the big ones. So we talked about a buffer overflow. We'll be exploiting this a lot. I'm teaching the exploit development class again next semester, and we do a lot of buffer overflow. We do all these really. Then you got race conditions, time of check, time of use, where your code saves something and then it comes back later to read it, but it's possible that something else changed it in the meantime and you didn't think of that. That's called a race condition, where there's a brief period of time when you can do something you shouldn't do. This is very often how you escalate privileges from a limited user up to administrator or root. There is, you do a high privileged activity like changing a password, which elevates to root briefly, and you find some way to crash it while it's elevated or to insert an extra command in there while it's elevated. Cross-site scripting is a big thing on websites, where you can put data in that's supposed to be a comment or something, but you can add script in, so when other people look at the page, that script runs in their browser and does something unexpected. It basically, like all these do, they give you the right to change the content of a page, which only a developer should be allowed to do. You just as a user are able to put something on a page which will run on somebody else's machine. Cross-site request forgery is similar, where instead of just running a script in one location, it runs a script which sends a request to some other site. So I could put a malicious link, I could have, say, a product I'm selling on eBay, and then I get to put in a description of the product. And if they have a cross-site scripting flaw, I could put an extra code in there, and I could make a script that runs on your page that buys a book at Amazon. It makes a request to a different site than expected, and it will work if you happen to be logged into Amazon, that kind of thing. Privilege escalation, I mentioned, this is where you somehow move from a normal user up to root or administrator or system. It's not supposed to be possible, that's the whole point, but in fact there's an endless series of these flaws on every operating system. Horizontal escalation is where you move into another user's account, and you don't want that happening either. Backdoors are where you have a built-in shortcut into a system that will give you remote control. Sometimes these are left in systems by the developers. Cisco keeps doing this. It's ridiculous having a secret password into their devices. And of course, you're not supposed to. People used to do that decades ago. You'll see it in the movie Tron. It was standard at that time. And the other thing is, of course, you put malware on the machine. It gives the person backdoor access to your devices. So if you find a vulnerability, then you go through disclosure. If the company has a bug bounty process, then there's an official way to report a vulnerability, and they might actually listen to you. If not, then you got a problem. A full disclosure is where you don't even bother warning the company at all. You just publish it openly on some website everybody knows. Now all the users of that product are vulnerable until the manufacturer improves it. What's considered more, you have the right to do this in America, according to my lawyer, but it's considered unethical by the community. Most people don't like it. They prefer responsible disclosure, where you tell the vendor privately they have a flaw and you give them some time to patch it. And typically you give them something like 90 days or 30 days, and then you can dump it publicly. This is what I always do. I've done this hundreds of times. Nobody ever cares, but I give them a chance to fix it. Then when I just put it in homework and tell the whole world, people aren't mad at me. If you just go full disclosure all the time, then a bunch of people will think of you as unethical and disgraceful and not like you. write nasty blogs about you, not hire you for consulting, and otherwise, you'll have a bad reputation. So to avoid that, I practice responsible disclosure. So the capability maturity model is from Carnegie Mellon. This is a way to create quality software. So you have your initial level of capability where you just do something, but it's not really controlled or organized. Then you have repeatable, where you have project management, so you actually control the steps, and therefore you can do another project the same way. Then you have a documented, standardized process, a controlled process where you measure the quality, and then an optimizing process where you define what you're trying to do, you measure to what extent you succeeded, and you keep improving your process to more accurately achieve your goals. These are different levels of software development maturity. Acceptance testing is an international board that has user acceptance, operational acceptance, contract acceptance, and compliance acceptance, just various levels. There's security impact of acquired software. If you buy commercial off-the-shelf software, then you've got vendor claims. They will tell you this thing is secure, but is it really secure? That's why you like having security researchers out there that will investigate these things, and you can consider the reputation of the vendor. You can consider how stable their finances are. Are they going to go out of business? And so on. If you have custom developed third-party products where you hire contractors to write code for you, then you consider service level agreements and their reputation and stuff. I know a college where they're always in trouble because they have custom software written by sort of sleazy, unreliable vendors who do a bad job and then just vanish, and then you're stuck with like a broken product that you can't maintain. All right, and then of course artificial intelligence is all the rage. So you have expert systems. There's a knowledge base which has rules that an expert system uses to make decisions, and then you have an inference engine that follows the tree defined by the knowledge base. This is the old-fashioned AI, not the modern large language model, but the old kind, like a troubleshooter kind of thing that pops up. And then you have the modern networks where you have a whole bunch of little processing nodes that combine inputs. So you feed in input, and there's a layer of input nodes, then there's a hidden layer, and usually many hidden layers, to combine some output nodes. This is what large language models do in all the complicated other AIs, and I've got a whole course in that I teach now and then. Although I'm not teaching it this semester or next semester here, I'm trying to get it in at 2 colleges I work at. Neither of them can get their curriculum committee to move and make it an official course, though. I'm teaching it at conferences and stuff, though. Anyway, it's very interesting stuff. And Bayesian filtering will just look for the probabilities of words in spam versus good email and just use if-then statements to decide true or false, whether it's spam. This is quite ineffective. The criminals have figured out how to get past this by randomizing words. Then you got genetic algorithms and programming, which simulate evolution. So you create an initial population of random programs, then you execute them and decide which ones are more fit. Then you create a new population by combining the ones that are best succeeding. This is more or less what forests do, forests of decision trees, which I've got in my machine learning course. It's more or less what they do here, although they don't consider sexual reproduction. But they do have a bunch of random processors, which they then combine to get a better answer. Anyway, let's try the last Kahoot. All right. So which flaw is common in C? Buffer overflows are caused by C because this thing they call a string is really a byte array. And programmers get confused by that. Anyway. Okay there? All right, which flaw is also called a race condition? Time of check, time of use, where there is a brief period of vulnerability and you have to win the race to exploit it. All right, which risk might cause a user to perform an unintended action like ordering a book from Amazon? Okay, that's cross-site request forgery. You have one page that has a script which causes a request to a different server. All right, and what's Carnegie Mellon's software quality framework? That's the capability maturity model. All right. All right. All right. Good.